Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Abdul Halim here. In the last video, we talked about three sets of numbers, right? Three set of numbers, right? The first one, we talked about natural numbers. We use the symbol capital N to represent natural numbers, and the element of this set starting from 1, and then 2, 3, and so on and so forth up to infinity. And natural numbers sometimes we call counting numbers, right? Then we proceed to whole numbers. Okay, the symbol we use is capital W starting from 0, and then 1, and then 2, and then 3, also goes to infinity, right? This is whole numbers. And then we have what we call integers, right? Using symbol capital Z. Starting from negative infinity, then we have negative 3, negative 2, negative 1, then we have 0, 1, 2, 3, also goes to infinity to the right, going to negative infinity to the left, all right? And 0 in the middle. All these numbers, okay, is called set of integers. For today's video, we are going to discuss one more set of numbers that we call rational numbers. Okay, now suppose that I have an object, okay, like this, and then I want to divide it into two equal parts. Then I am going to shade one of them, for example, this area on the left. And I want to write this part as a number. Must be equal to 1/2. That is one part from two parts. But the set of numbers that we discussed so far, that is natural numbers, and then whole numbers and also integer, does not include fraction numbers like this. Okay, does not include in any of the set that we discussed so far. Therefore, now we are going to introduce, okay, one new set of numbers that we call Q for quotient. That is a set of rational numbers. This is a set of rational numbers. Okay, and the definition for rational numbers is like this: equal to, okay, the set of P over Q such that P, Q must be integer, and Q, that is the denominator, must not equal to 0. We won't allow the denominator equal to 0. And I'm going to explain in a little bit why we cannot allow Q equal to 0. Therefore, the number like 3/4 is a rational number, okay? Because 3 is an integer, okay? That is the numerator is an integer. Now 4 here at the denominator, 4 is also an integer, all right? And it is not equal to 0. The denominator is not equal to 0. Therefore, it's fulfill all the requirement to be in this set. Okay, number like 5, for example, 5. Now, is this number is rational? The answer is yes, because 5 can be written as 5/1, where 5 is an integer, okay, 1 also an integer, right? Now, how about negative fraction like this, negative 11/6. Now, is this number rational? The answer is yes, because negative 11 is an integer, right? 6 also an integer. Now, how about 0? 0. Is 0 is rational? The answer is yes also, because 0 can be written as 0/Q. Okay, where 0, okay, is an integer, and Q can be, is an integer as long as it is not equal to 0. Now, we are stressing so much that Q must not equal to 0. Why is that? Because Q must not equal to 0, because if Q equal to 0, what happened? Okay, if Q equal to 0, what happened? this fraction here, P over Q, and Q equal to 0, Q is 0, so P over 0 is undefined. Anything, any number divided by 0 is undefined. That's why we won't allow the denominator is equal to 0. As we all know, fraction can be converted to decimals, right? And decimal, at the same time, can be converted to fractions. Now, if we are given, for example, numbers like this, 1 over 3. Yeah, we know this is a rational number if it is written like this, but if it is written in the decimal form, for example, this is equal to 0.333, like this, without ending, or we say non-terminating, repeating and non-terminating. Okay, it is repeating and non-terminating decimal. Okay, this type of decimal is said repeating because 3 is repeated many times. Okay, many times, infinitely many times. Non-terminating means, okay, there is no ending, continuously, forever. Okay, so 1 over 3 is equal to 0.333333 forever. So we say it is repeating and non-terminating. Okay, so now if we are given the decimal form, okay, we know if we have a repeating and non-terminating decimal, we know this is a rational number. All right, now let's give another example. For example, 7 over 11. Now, in the form of decimal, we have 0.6363 and so on. Or we write it, okay, to simplify writing, we say like this, 0.63 bar. Means 63, this digit 6 and 3, okay, it is repeating and non-terminating, meaning it continues forever, repeating, okay, again and again without ending. The same thing here, 0.33, okay, dot means it's repeating and non-terminating. So we can simplify writing like this, 0.3 bar. Okay. Therefore, if we see something like this, we know this is also a rational number, okay, without looking at the fraction part. Now, if we have something like this, 1 over 7, very interesting. What is this equal to when it's written in decimal form? It is 142, okay, 857. 857. You know what? These digits, this 6 digit, repeating itself. Therefore, we are going to put bar, okay, over this number because it's repeating. So 1 over 7 is equal to 0.142857. Again, 142,857, and so on and so forth, repeating, non-terminating. Okay, therefore, when we look something like this, we know this is actually a rational number. There is another one that is even more interesting, that is this number, 19 over 17. If we convert, okay, into decimal by using maybe computer, not our calculator, because it won't be able to give all these numbers that we have, it is equal to 0.1176 470 588. We have 235, and then we have 294. I hope I got it right. You know what? We have bar over the whole of this number. Meaning, 19 over 17 is equal to 0. This whole number here repeating itself and non-terminating without ending. Therefore, this number also is a rational number. Okay, this is the first category of decimals that represent a rational number. Okay, that is, that number must be repeating and non-terminating. Okay, then we see that that is also a rational number. Now, there is a second way of deciding whether a decimal represent a rational number or not is by looking at the decimal, whether it is stopped at a certain point. We say terminating decimals. Terminating means stop. Okay, for example, if we have 0.2, 0.2 stop. Okay, there is no other digit after 2. This means that the decimal terminate, stop, ends after 2. Okay, is this what we call rational number? The answer is yes. Okay, because it's terminate after 2. So this one is actually 1 over 5, right? Now, how about 0.25? Okay, after 5, there is no other digit. Means it's terminate, it's end after 5. So, is this represent a rational number? The answer is yes, right? Actually, this one is equal to 104 in terms of fraction. Okay, now if we have 1.625, also this number stop after 5. All right, therefore, this decimal represent a rational number. Actually, this one is equal to 13 over 8. Now, let's give the last one. 2.1, 3, for example, 7, 5. And after 5, there is no other digit. Means it's terminate, it's stop. Okay, therefore, this decimal represent a rational number. Actually, it is equal to 171. It is over 80. Okay, that's the way how to decide whether a decimal represent a rational number or not. If it is for this category, if it is stopped after a certain point, then we say, okay, that decimal actually represent a rational number.